Hello, today I want to talk about FTC 2, the proof of this, and the proof involves the result of FTC 1, which we're going to get to in a little bit. I'm kind of doing these out of order because I wanted the result of FTC 2. We saw that before. So the proof, FTC 1 says that if g of x is, well, let me erase this for a second. If f of x is continuous on the closed interval AB, and g of x is what's called an integral function. It's the integral from a to x of f of t dt, where x is in the interval from a to b, that's the domain of g of x, then g prime of x is f of x. We'll see this again more later on, but I need this result. So, the proof of FTC 2. Remember, let me write over here, the result of FTC 2. If f is continuous on the closed interval AB, then the integral from a to b of f of x dx, this number, is equal to capital F of b minus capital F of a. This is what FTC 2 says. And we used that previously. So, the proof. Let g of x be the integral from a to x of f of t dt. I'm creating this integral function by FTC 1. G prime of x is equal to f of x. That was the result that I gave there. We're not going to prove that result. We're going to take it on faith even when we talk more about FTC 1. So, but g prime of x is f of x. Therefore, g of x is an antiderivative of little f of x. Let capital F of x be any antiderivative of little f of x. Then capital F of x is equal to g of x plus c. All antiderivatives differ by a constant. Now, g of a is equal to the integral from a to a of f of t dt. This is basically the area under a point which has to be 0. We're now ready to do the algebra part of this. Let me box this off. So, capital F of b minus capital F of a, substituting in, that's equal to g of b plus c minus g of a plus c. That's what capital F is, which, looking at the algebra, the c's are going to go away. This is g of b minus g of a. I just said g of a is 0, so this is equal to little g of b, but substituting in, this becomes the integral from a to b of f of x dx, of f of t dt. Getting ahead of myself. The variable on the inside is called a dummy variable. It doesn't matter what variable we use, and so therefore this is the same as the integral from a to b of f of x dx, which is exactly what I wanted to prove. And so we're done. Very simple, very nice, very elegant, and very powerful.